I'll start today with a brief introduction of IMSC, which is this subtitle format many of us have been working on for now a number of years, and I think it's pretty remarkable because it's really one of the few end-to-end formats for subtitling and captions. So all the way from production all the way to emission and client devices. It's a W3C recommendation, so that's from the same organization that standardizes XML, CSS, and HTML. It's designed for end-to-end format, so both for production as well as for emission. It's intended to be used worldwide, and for subtitles, caption, as well as karaoke. It's based on a time text markup language, which is a generic language for marking up text with temporal information, and it's deployed today end-to-end. I think from the beginning, the objective of IMSC was to bring together the very, very many different flavors of subtitle and caption formats out there, and especially the many flavors of and profiles of the time text markup language. The time text markup language, I think, suffered from its flexibility, and many folks adapted it to their own needs, and we ended up with a very large number of profiles. And IMSC is really intended to bring all those profiles back together into a single practical single format for subtitle and captions worldwide. And some of those other formats you might have heard of, such as SMTTT, which was designed for the North American market primarily, EBUTT for Europe, ArriveTT for Japan, and others. So some of the milestones for IMSC. So the original IMSC recommendation was published in 2016. IMSC 1. It was followed up pretty quickly with IMSC 1.01, which was published in 2018. And that IMSC 1.01 obsoletes IMSC 1 and fixes some pretty serious bugs and adds some really essential features for European subtitling and captioning. And so really the short answer is never use IMSC 1, and always, if you're going to use one of the early version, IMSC 1.0.1 is the one to use. IMSC 1.1 was the following version, published in 2018 also, and this really brings critical improvements that are really needed for subtitling and captioning worldwide, in particular advanced Japanese language features and support for stereoscopic 3D and HDR, so high dynamic range presentation. So really, if you're going to start with IMSC, and especially if you're targeting worldwide distribution, IMSC 1.1 is the specification to use. There's a more recent version of IMSC, IMSC 1.2, that was published just earlier this year. It brings really minor improvements, and I would say editorial improvements primarily, but also adds support for downloadable fonts. So IMSC, again, intended for worldwide use, so supports very, very broad range of variations of human language, which has many of those variations. So of course, very simple, very simple styles, for instance, italics, bold, underline, to very complex styles such as Ruby, annotations on Japanese text, and this is what we see here, where there's a baseline text, and on either on top or bottom of this text there's annotation text. Also vertical writing, of course, right to left, background colors, text outline, very important when you have text over a background. So IMSC supports all those styles and writing modes. It also supports both text and image. And image subtitling is still used in some use cases. Of course, the recommendation, if there's ever image subtitling, that it be always accompanied with equivalent text subtitling for accessibility. As I mentioned earlier, it supports stereoscopic 3D and high dynamic range imaging. So both support for PQ and HLG for those that are following the high dynamic range drama. Just a very brief overview of what an IMSC document looks like. It's a pretty straightforward XML document, human readable to the extent that XML is human readable. And the basic structure of an IMSC document is a number of regions are defined, and these are rectangular areas within the root container, so within the video essentially, and then text is flowed into those regions over time. So pretty straightforward model. Again, one of the key objectives of IMSC was to really work well with other formats and try to reduce fragmentation rather than increase it. And so, for instance, in the case of SMPTT, which is again was designed for the North American market, in practice, all SMPTT documents are also IMSC documents, so there's likely no conversion necessary there. For other CA608 and CA708, which are very popular captioning formats in North America, there are SMPTE specifications, standards that define how to convert those captions and subtitle formats to IMSC. In the case of EBU-TTD, which is a emission standard in Europe, again, no conversion necessary to IMSC1, but for very corner cases I've never seen so far in practice. So basically every single EBU-TTD document is also an IMSC1 document. SDP-US, which is really maybe more for historical interest, an early profile of TTML, and again, no conversion necessary to IMSC1. For EBU-STL, there are standards for converting EBU-STL to EBU-TT Part 1, and from there it can be converted to IMSC. WebVTT, there's actually a draft mapping from WebVTT to IMSC. And again, this is really the lesson here is one of the key objectives of the project is to reduce fragmentation and increase it and try really hard to include all features that are necessary for subtitling and captioning worldwide. So if you start using IMSC and you find a feature that's missing that's really critical to your territory, your region, please do let us know. In terms of adoption, it's been adopted pretty broadly. It's the subtitle and caption format for the interoperable master format, which is a format that's increasingly in use for high quality studio masters. It's also the one of the time text format in the CMAF, MPEG CMAF specification for segmented media. It's been adopted by DVB, by ATSC, CTA Wave. It's also available in HLS and on iOS devices, and also by Apex, which is the airline standardization group. And I'm probably missing some. So one of the things that I think that's pretty interesting here is it's really available end-to-end today. And what I mean by that is from mastering, so from studios all the way to the consumer device. And this is really an opportunity to create great subtitles very early on and make sure that they're displayed as intended to the consumer device. So as opposed to, for instance, image that often undergoes modifications from the time it's created to the time it's actually displayed to the user. Similarly, also for image and for audio, IMSC is really intended to remain unchanged all the way across the chain. So from mastering to an online service like Netflix to ultimately the consumer device. So, you know, IMSC would have not been made possible without really international collaboration, and folks like Andreas Tai have been really instrumental in this, and others at the BBC, like Nigel Megget, within ATSC, Mike Dolan, and so forth. But it also would have not been possible by the multiple open source projects around the format. There's open source validators, the time text toolkit. There are multiplexers for including IMSC in ISO BMFF. There are open source players, for instance, the -js web player. There are libraries for wrapping it into production formats like MXF, and there are a number of open source video players like Shaka Player, Exoplayer, VLC that include some compatibility with IMSC. What I'd like to discuss a little bit more detail today are some of the projects that I've been really more closely involved in, and the first one is imscJs, which is a JavaScript library that renders IMSC documents through HTML5. And this is, I think, pretty critical because, ultimately subtitles are intended to be, will likely be played back on web devices, whether mobile devices or PCs, and the ability to reliably render IMSC to HTML5 is really critical. And so this has been, again, a project that's been a couple of years in the making. It's been supported by a number of folks over the years, primarily by Movie Labs, who's a joint venture of Hollywood Studios, and by Netflix. And open source, it's published on GitHub under a BSD license. And it's really intended to be a complete implementation of IMSC across all its features and really be the reference IMSC renderer. And without further ado, I'd just like to show you a little bit how it looks like. So this is what you're seeing right now is just a simple demo web application that implements or that uses IMScJs to render TTML files, IMSC files, and I can just open a file, for instance, here. There we go. And we can simply step through the TTML file. There we go. Again, this is not intended for production, but just for inspecting IMSC files. It's also a demonstration of some of the features of IMSC, for instance, right to left, some vertical text, some annotations, some shearing in Japanese text here. We can actually see what this file looks like, what the source file looks like. Maybe I can just put it here. There we go. So that's the source file. And again, this is the results of rendering it to HTML5. So again, so the purpose of IMScJs is to be reference renderer for IMSC for the complete standard. And it's, for instance, it's used by the -js reference player. And here's a little demo of what it looks like. Hopefully, there we go. So here the video is played by dash.js, and the subtitles, well, the captions here are rendered by IMScJs in real time. And this is also a demonstration of the different kinds of styles of captions. So this is a roll up, where every new line replaces a previous line and the subtitle rolls up. Can also, of course, works with paint on captions, assuming that we can actually get this started. There we go. So this is pop on, where captions just appear and disappear. And we can try pop on. There we go. Where words appear over time. And so this is both a demonstration again of -js which is a reference player for segmented media, for IMSC, which can support all those 3 styles of captions, and from imscJs you can display them in any web browser. So again, if you're interested, please check out imscJs on GitHub. Please contribute, file issues, try it. This is really intended to be a community project. One more thing, so I thought this would be a really good opportunity to introduce a new project that a few of us have been working on, and for the past couple of months. And the project is ttconv, completely boring engineering name. Again, hosted on GitHub, so an open source project. Again, uses a BSD license. It's a Python library with a command line application, and the goal of the project is to provide a open source framework for the conversion between caption and subtitling format. Even though it'd be really ideal if the entire world had settled on IMSC, and perhaps one day will do, it will. In the short term, there are many caption and subtitle formats, even within a given territory, and the purpose of this project is to define a framework for the conversion between caption and subtitle formats when, for instance, not everything can be kept in IMSC. Project is currently in beta. It's been supported by Facebook, but again, this is intended to be an open source project with community is really invited to contribute. And so, please again, check it out and follow the project, file issues, and just to help a little bit maybe understand how this works, how the framework works, the architecture. This is an illustration of the architecture of the project. Knowing that there are going to be a lot of input formats and output formats, the framework defines a common internal model, a very flexible model. It's actually based on TTML, although it's not identical. And the basic idea is to take input formats, each input format converted to this internal model, and then convert that internal model into any number of output formats. So today, in the beta, what's supported is SCC, so CA 608, 708, or IMSC as input, and as output SRT, which is a kind of WebVTT Lite, and IMSC. And over time, I expect other formats to be added. Just to help us kind of see what it looks like, I put up a little demo here. Let me switch the application. There we go. Yeah. Okay, so back here. So at ttconv.sandflow.com, again, everybody can access it. Forgive like the kind of, it looks pretty bare and simple, but again, this is really intended to be just a toy demo. So you paste the input time text on top and you get the result at the bottom. So here what we have on top is SCC, so this is 608, 708 captions, and they're really readable hexadecimal format. And I can convert them to IMSC here, which what we see here. So this is done in real time. I can also convert them to SRT. There we go. If I go back to IMSC, there we go, and you'll have to kind of trust me that I can go here and open the output of the conversion. There we go. So this is the result of converting 608 captions into IMSC. Again, this is just, I'd say, in beta form, so complete, but would certainly benefit from more sample content, more people experimenting with it, and filing issues. And again, this is a tool that's really intended to it's a framework that's really intended to facilitate conversions across common and popular subtitle and caption formats.